Now let's look at some examples that apply the area between two curves. Example D, suppose a company has a revenue flow modeled by R of X equals 1/3 X squared plus 2, and a continuous cost function of C of X equals the natural log of the quantity 2X plus 4, where X is in years since they started. They want us to find the total profit for the first 10 years of business. Let's recall that profit equals revenue minus cost. So we want to find that area between the revenue function and the cost function. So the first 10 years would be from 0 to 10 of our revenue function minus our cost function. And again, we can put this in our calculator and we get approximately $105.75. Let's go back and make sure it's not in thousands. Did not say. So it is approximately a total of $105.75 for the first 10 years of business. Yeah, business isn't doing that great. An example E, in the late 1900s, imports from Japan was modeled by the function I of X equals negative 0.61 X cubed plus 8.31 X squared minus 27.42 X plus 114.37, where I is in billions of dollars. And X is the number of years since 1988. Exports to Japan was modeled by E of X of negative 0.12 X to the fourth plus 2.28 X cubed minus 13.93 X squared plus 32.78 X plus 23.22. Find the U.S. trade deficit with Japan between the years 1989 and 1996. So a couple of things to remember. X is the number of years after 1988. So if we're looking at 1989 to 1996, we're going to be looking at year 1 to year 8. And if we're wanting the U.S. trade deficit, then that means that our integral from 1 to 8 will be the imports that we've paid for minus the exports that Japan paid for. This is a very old example. So this is not a political example, 1 to 8, if we were to put all of that into our calculator, and you may even want to simplify that subtraction, combine like terms to make it a little bit easier, but we'll get approximately $357.87 billion.